All right, hey, honors chem students, I wanted to go over the answers to the stoichiometry review so you can watch this prior to taking the Unit 9 stoichiometry test. So let's go right into this. When 100 grams of salicylic acid reacts with acetic anhydride, according to this reaction, 50 grams of aspirin was actually collected. What is the percent yield for this reaction? So, from this, the number we can use immediately is the 100 grams of salicylic acid. So we know that's a start point. And then we know how much aspirin was actually collected, 50 grams, but we can't use 50.0 grams in this table because that's the actual yield. We need to use stoichiometry to find the theoretical yield. So that means our finish line is right there in that box for the aspirin. So we just do normal stoichiometry. The key to problems like this for a lot of you continue to be making sure that you have accurate molar masses. So the molar mass of salicylic acid is 138.13. Make sure you're tedious when you add up all those numbers, 7 carbons plus 6 hydrogens plus 3 oxygens. We're going down, so we divide 100 divided by 138.13, and we get 0.724. There's a 1 coefficient in front of the salicylic acid, so easy division. 0.724, we carry that same number over, and now we go back up, multiply. There's a 1 in front of the aspirin, so still 0.724, and then again that molar mass, critical that you add this correctly to get 180.17. So now we take 0.724 times 180.17, and we get our theoretical yield of 130. Now we can plug that into our percent yield equation. Actual, 50 grams, divided by theoretical. And remember, the 50 grams came from the problem. The theoretical yield is right up here in our stoichiometry table. And then we'll multiply by 100. And the final answer is 38.46% yield for the aspirin. Number 2 is a typical stoichiometry problem. So 72 grams of pure phosphorus reacts with excess hydrogen. How much phosphorus trihydride is made? First of all, it's balanced, so we check that. Start point is the P4, 72.0 grams. Finish line, the pH3. So, molar mass, add 4 phosphoruses together to get 123.88. 72 divided by that number gives us a 0.581. There's a 1 in front of the phosphorus. So simple math, division, still gives me 0.581. Carry that number over, and we get 0.581. Now we're going up, so we multiply by 4 to get 2.32. And then the molar mass of pH3. Remember, never use a coefficient to calculate a molar mass. It's only 1 phosphorus plus 3 hydrogens. And that comes out to 34.00. So 2.32 times 34.00, sig fig wise, gives me a final answer of 79.0 grams of pH3. Last one is our limiting reactant problem. Sulfuric acid reacts with sodium hydroxide according to the reaction below. So the first thing you had to do was balance it. So we had to put a 2 in front of the sodium hydroxide and then a 2 in front of the water. And then next, what is the limiting reactant if 0.75 moles of sodium hydroxide? So I can have a start point there. And I'll just go ahead and write in the word start. And then reacts with 1 mole of sulfuric acid. So that's our start point. So remember, how to find the limiting reactant is to go to the carryover line. So let's do that for each of these. 1 divided by 1, 1.0. 0.75 divided by 2 is 0.38. And right now I can answer what my limiting reactant is. It is the smaller number. So the smaller number is 0.38. That means my limiting reactant is sodium hydroxide, NaOH. Then it says, what is the amount in grams of the excess reactant that remains after the reaction? So I have to split the sulfuric acid column in half and now put that smaller carryover number, 0.38, down there and take it all the way to the top. So times 1 is 0.38. Then I had to find the molar mass of H2SO4 is 98.09, so 0.38 times 98.09 is 37. And then I still can't answer the problem because I have to go over here and figure out how many grams of sulfuric acid I started with. So there, 98 grams. So that means I started with 98 grams of sulfuric acid and I used up 37 grams of sulfuric acid. So how much is left over? That's what the question is asking. If I start with 98 and I use up 37, that's 98 minus 37 to give me a final answer of 61 grams of sulfuric acid that is left over after this reaction. Then the last question, what mass of each product is produced? So now I take that smaller carryover number and put it down here at the bottom for each product. And we'll just do sodium sulfate first. Times 1 is 0.38. Molar mass is 142.05, so 0.38 times that gives me 54 grams of sodium sulfate. Sig figs matter, sig figs matter. Now let's do water. There's a 2 in front of the water, so 0.38 times 2 is 0.76. The molar mass of water is 18.02, so 0.76 times 18.02 gives me a final answer of 14 grams of water. So there you go. There's your stoichiometry review. Your test, your stoichiometry test, will be very, very similar to this review. Good luck. Talk to you later.